Hey everybody, I'm going to hold on one second, you guys. Just trying to set up here. I would like to make chat sub only. Man, YouTube needs to get better at their chat, at their live stream like settings and functionality and mods. It's like really hard to find stuff. And like with Twitch being such like a trash service lately with bots and with the creators on there, like YouTube has such an opportunity being the conglomerate it is in video right now, taking over TV and everything to just be the biggest monopoly ever in media, but it just won't do it for some reason. Google just won't do it. With streaming, they just won't take it over. It's so annoying. I'm waiting for it to happen. Okay, we want to do general. No, okay, let's just save this. Okay, so let me look it up. How to make. My like neck hurts. Need to chill. Like straining my neck. Straining my neck. Okay, go to studio. Can I not do this? What's going on here? Okay, click on details. Oh, what? Messages in your live chat, posts on your community, but it's not in there. Hold up, you guys. Give me one second. We're gonna get into a fun stream today. Hey, what's going on, Savior? Thanks for joining me today. Give me one second, you guys. I'm trying to figure out this. Content. Show more light chat. Okay, content. Okay, here we go. There we go. Okay, I found it. Jeez Louise, that was terrible. Okay, cool. I think we're good. Let's get into today. Yeah? Alright, you guys. We should be okay. I'm trying something new, making chat sub only. Hopefully it gets rid of some of the trolls. But everybody seems pretty chill so far, so we should be okay. Anyways, let me know how the audio is and whatnot. But let's go ahead and get into today. It should be a fun stream. I should learn a lot today. We're going to be building a shell in C using the Codecrafter's shell, make your own shell course. I feel like this will be very helpful for our current C programming studies that we've been doing to build a project, something challenging. Also, with helping understand the computer a little bit better by building, a shell, and then we can translate that into understanding better, shell scripts altogether. So this should be a fun one. I hope you guys are. If you guys are interested in doing this alongside me, this is a free. Again, I don't pay for anything. I'm cheap. I'm real cheap. That's why I save money like no tomorrow, and I into the stock market. I don't pay for nothing besides food. So I this is the free. I just make a free account. This is one of the free offerings here. So if you want to do it alongside me, now's your opportunity to join me here. We are going to be getting started. Yeah. So let's go ahead and jump on into this today. So we're going to git clone a certain file here. Okay, I'm not going to copy this text. This is just a git command, so I'll paste this one. Okay. And then we have just this test CLI connection script here, which we curl into the code crafters to install. Is this an and bash? Code crafters ping. Okay, so we're just gonna make sure it did it right and download it here. All right, here we go. Looks like it did that automatically. Nice. Write code on your machine. The Git repository you cloned in the last step is where you'll make all your changes. Getting some basic C code to get you started. Run codecrafters submit. Once you're ready to test your code, simply run codecrafters submit. You'll receive instant feedback in both your terminal and browser. Interesting. View first stage. Okay. Oh, hold up. Don't go yet. All right, this is fun. Whoever set up the site, it looks pretty nice and it's pretty cool. So let's go ahead and get started here. So this is our shell here, or our terminal. Ping received, and we're just back in here. Okay. And we're back in the browser. Okay. Um, so I guess we gotta watch this video here. Let's get going.
A dollar sign. That's the prompt in this case. Our job in this stage is to implement exactly that for our shell. Cool. So since this is the first stage, I'm going to show you how it's done completely. But if you feel like trying it out by yourself, you're welcome to skip this video. First, I'm going to open the code base that we just cloned in any code editor. This is a Python
So what was
code
our
base.
goal
So
here? Our
stage,
goal
I'm
is
going to
what?
show stage of this exercise is going to be printing a prompt. I've got my terminal open here to show you what that means. As you can see, the
Hey,
shell
human,
has
how's it going?
printed a $sign. That's the prompt in this case. Our job in this stage is to implement exactly that for our shell.
Okay. I think I might be able to do that. I don't know. Let's try it. Um, okay. Welcome in, everybody. This is the Code Crafters Building Your Own Shell in C, episode 1. It's 11 p.m. Oh, wow. It's 10:23 a.m. West Coast United States here, California. That's crazy. Okay. So, um, flush after every printf. To do, uncomment the code below to pass the first stage. Okay, so yeah, it wants us to print f here. And then do we need to... Oh, well, we're doing int argv char argc already, argv here, so it's already set up. So I think let's just kind of keep watching. We're getting a little ahead of ourselves. We're excited.
Cool. So since this is the first stage, I'm going to show you how it's done completely. But if you feel like trying it out by yourself, you're welcome to skip this video. First, I'm going to open the code base that we just cloned in any code editor. This is a Python code base, so there's going to be a main.py. By the way, if you use a different language, the workflow will be the same. Just the starter code is going to look a little different. And since this is the first stage, we've actually already provided the solution for how to solve it. In this case, it's basically this line. Let me quickly get rid of this to-do statement. Now, if you don't really
He's doing it in
understand,
Python. We're doing it in C. Uh-oh, this might be hard for us here, but it's going to be a good challenge. It'll be a good challenge.
what this code is doing, it's not really a big deal. I'm sure you'll pick it up along the way. What's happening here is we are writing a dollar and space as standard output. We aren't using print because it would attach a new line, which we don't want. And so at this point, the code is looking good and we're ready to ship it. So all I need to do is type code crafters submit.
Okay, so that's how you do it. Okay, that's right. Is it all one word? Yeah, sorry. Okay, so... Oh! Let's go! Nice. Alright, test pass. Mark stage as complete. Submit code and proceed to the next stage. Okay, view next stage. Okay, so we're just printing a $sign. That's it. So, and then we're doing argv argc to receive commands, right, um, from the terminal here for what to run for our shell. Like these are like, now, this is gonna be good because the shell is like coming from non-computer science. Like it's this like mythical, like overlord that like seems like so abstract and so like obfuscated and just like I don't know, it's just this weird thing that you don't want to touch or mess with because you think things will break and if you start doing stuff. So this will be really good to get more comfortable with this, actually building one ourselves, which will be really nice. Okay, so our task in this section here, in this stage, you'll implement support for printing error messages for invalid commands. Example. So we have some command, and then we say command : we would reprint the command and then say command not found. Your program should display the prompt $, keep the code from the previous stage, read the user's input, print an error message in exactly this format. Command not found. If the user types XYZ, print XYZ command not found. For now, we'll treat all commands as invalid. In later stages, we'll handle executing valid commands like echo, cd, etc. Okay. Okay, so this is, we'll just make a comment here. Sorry, we're in C, not Python. And we're going to say that we're going to read the user's input here, right? So we have variables here. Why are making the dogs whine? We have variables here stored as pointers into argv, right? So we can access them here. So we just need to say like if argc is equal to 0, or well, is less than or equal to right, so length of 1 would be the file name, length of 2 would be the, hold up one second. Okay, so if argc is less than or equal to, so like the argument count, let's go back to my C programming notes real quick here. So we have, I remember in our string in chapter 13, we took note, I haven't just done argc, argv in a long time. But we just read about it though. We haven't got any practice yet in a long time. So please tell me I took notes on it. Here it is. Okay, argc, the argument count, we know that. It's a number of command line arguments, including the name of the program itself. So 0 in argv, index 0, okay, that's just in the argv array, right? But argc is the counter. So 1 is the program name in the counter, from the counter point of view. And then, so you need to be greater than 1 in order for this to actually read. That would, okay, got you. Because you have program name, and then in position 2 you have the, or index 1, you would have whatever command you would want to run. Right, because that's what we're doing here, is just, oh no, well you're not running a program actually, you're just running some sort of command. So you're looking for, okay, got you. So the arg count less than 1, then we'll say that we'll just printf the no command entered, something like that. Maybe we're just getting too custom here, but whatever. And then we would just return 0 here. This program would end. Would you return 0? So now we have, let's say in the case that we have commands, we want to say it's not found. So so we have commands, but we have commands greater than 1. Can you have, well, you'd have to, that's the thing, is I'm maybe getting ahead of myself. We catch up on some chats here. Hey, you're from Los Angeles. Nice, dude. Code Crafter Shell is my go-to language in Linux. We got a lot of people here. People like this one. Okay, cool. So I'm trying to challenge myself to see if we can try it before looking at hints, right? So we know that the user's command is going to be in a pointer to the string of characters in argv, right? So we would say like, um, come on, Mike. We just did strings. We just started learning. We read that chapter. Wake up here. Wake up. Okay, so we would, um, because you have to loop over. We know it's a pointer to that place. We can use pointer arithmetic to move forward. Okay, so we have this is where this is ah. Okay, we're no longer doing simple little problems here for right in our book. Um, so I guess we could have char star p is equal to argv index of 0, right? We point to there, and then we would just um, dude, this is where C gets so much more difficult in Python. Is now we need to match. Do I go for the hint one? Struggle's real here. Okay. I think we should warm up here. See. All right. Okay, we'll go for the hint one. How do I read the user's command? Use the fgets function. Okay, wants us to use a function here. Captures user command variable. Char command. Fgets command. Size of command standard in. The fgets function waits for the user to enter a command and stores it, including a new line in the command buffer. So, but does it? So you have a buffer of characters here. Command fgets into command. Size of command. Waits for user to enter a command and stores it, including a new line in the command buffer. And then standard input. Captures user command in the command variable. Right, this is a variable array of 1024 bytes. We do fgets for the variable we want to store in. The size of command. So the size of command for here. The manual page. Okay, that's a good idea. Um, oh, whoops. Fget is a built-in function in the standard I/O used to read a line of text from input. It stores the input into a character array and stops reading when it reaches a new line character, the specified numbers of characters, or the end of file. It is safer than getS because it prevents buffer overflow by limiting. Okay, so that's what I was thinking. We could use getS, but it prevents buffer overflow by limiting the number of characters to read. We can use it to read a full line, including white space from input, rather than stopping at the first space, like scanf would. Okay, so we have a buffer of things with a size in here. Enter a string. We're only going to have a buffer size of 10. We're going to read it into buffer and standard in. What is this third argument? Stream. The input stream, typically standard in for reading from the keyboard. Oh, so you have to tell it like where to read from. Okay. Okay, let's try it here. So we would have a we would do the thing is though, because you have this in the function, it automatically starts detecting for input. You don't have to like do like okay, maybe I'm just dumb. Okay, let's just try it. So we have buffer. Let's say command buffer with size. Wants us to it recommended a size 1024. So we'll keep up with that. So we have command buffer. So we have fget s, fgets into command buffer, right? And we're gonna have this is the size of limitation, right? And so we're gonna fill the entire command buffer if possible, right? So this will be size of command buffer. Ooh. And then we use the standard in to read from keyboard input here as our stream argument. Okay, so that will save all of the white space up to 124 or 1024 bytes of character input into command buffer. I guess we then say right, doesn't put s, let me go back to the let me go back to this guy and look up put s. String to be printed, return a value of string depending on the successful failure of execution. It'll just go until the end of line character. Okay, so until it reaches a null characters and count it, put s in counter. So we want to do we want to extract out the first the first thing, or just print f the do we put s the whole command buffer and just say not found, or do we just do the first until the first white space and get that value out, which would be like the command, right? Let's see. So we use the printf function, remove the trailing new line, stir c span command \n equals 2. So we remove the new line character and set it to a given command. So we have to define the type of this buffer array though, right? Yeah, so it is a char array of command buffer, right? We have the function to get input and save it into command buffer. We remove the trailing new line. So stir c span. Let's look at that. Ooh. For a C standard library, it defined in string h. Is used to find the number of characters in a given string before the first occurrence of a character from the defined set of characters of a string. So where const char pointer str1, the target string in which the search has to be made, and the argument containing characters to match in the target string. Okay. What does this stand for? Like this shorthand. So what's up everybody? How's everybody doing today? Okay. Let me put this over here. Okay, so we're gonna look for the in command index well, I don't really get this like examples. We have an array of characters and we have another array of characters. Calculate the initial characters before first matching characters. Size equals to this. What? I'm confused. The function returns the number of characters in the first string before the first occurrence of characters present in the second string. Oh. Oh, so it returns an index. So we call this, it returns an index of where this is, and we replace that with this. Ah, okay. Okay. So what we do is we have, um, I mean, we could loop and then find it, and then I'm sure that's what this does under the hood, but okay. So let's do, um, we'll just say new line index, right? We'll expand this out a little bit. So this is going to be int um, is equal to stir CSPN. What does that stand for? For the command buffer, right? We're gonna span the command buffer looking for the new line character, right? And we're gonna save that in new line index here. We are then going to index into our command buffer for the new line index and set that equal to quote. Oh, sorry, this is a single character. We're not in Python here. Let's see. Set this equal to quote \0, the null character. And so that will override the value. Now we can just print command buffer up to the null character here where the new line is. Does this span just the first occurrence? Let's read that one more time. As part of the C statement is defined in this function is used to find the number of characters in the given string before the first occurrence of the character from the defined set of characters or string. Okay, so it just returns before the first occurrence. So right, has Geeks for Geeks and this is KFC. So we have KFC. The number of characters, insert one first. Match characters from search. So they just match the K here with here. Because it's 3. And it just all doesn't match the full string. Because this is KFC. KFC is not in here. Let me look that up. What is it? Stir CSPN. Match full second arg. String complement span. The second argument S2 is the string containing characters to reject/search for. Oh, any character that exists in this one. So a K, F, or C, it first hits a K there and returns back 3. Okay. Okay. So then we can print F, right? Percent %S here. Command not found. New line given the command buffer. Oops, what am I doing? Right. So if we Okay. Now I think we do our thing. Code, crafters, submit. Okay, we have some errors here. Let's look. Maybe they don't want this. Include string.h. Let's compile this. Oh. Um, okay, so ISO and does not support implicit function declarations. Huh. So this is saying call to undeclared function size of. Huh. Let's see here. Okay, so something's not right here. Oh, did I put an, oh, whoops, sorry. I put an underscore. I think we still have an error though, right here. Incompatible integer to pointer conversion. So stir C span is part of our hint 2 here. Oh, which doesn't return back. Oh, it returns back a pointer? Okay, const char star is the return value of this function. I thought it returns an integer. Is it a pointer to an integer? Well, it says pointer to a char. I guess could be an integer, but returns a number of characters in the first string. Where's the return type? Stir C span. It takes in a string, not a character. It looks for a full string. Okay. Let's go. Okay. So what did we learn there? That was a lot, right? What did we learn there? Okay. We first set up if the arg count is less than 1, then there was no command entered. Right? We know that argc is our arg count for how many arguments are stored in our argv character pointer array. Right? We set up a command buffer to store we set up a command buffer to store the character inputs. We use fgetS to get the strings, right, into command buffer, capping at a size of command buffer, reading the stream of standard input, right? This function is stir. I always forget. It's called stir. Where are you? There you are. It's called stir string complement span. String complement span. Okay. Which will return back the index or the number of characters, right? Seen before the first matched occurrence of this, right? Any character in here. We replace this last character, right? Because this is zero indexed, we don't need a -1 from here. We replace it with the null terminator, and then we print out the command. Okay, cool. I think we are good to submit this one then. Nice. Oh, I'm done refactoring. Okay. Cool. Next stage. Let's go. Moving on up the leaderboard. Okay. All right. Cool. In this stage, you'll implement a REPL, read, eval, print, loop, or a REPL. Okay, that's what that stands for. Read, eval, print, loop. A REPL is an interactive loop that forms the core of a shell. It follows a repeating cycle. Read, display a prompt and wait for user input. Eval, parse and execute the command. Print, display the output or error message. Loop, return to step 1 and wait for the next command. Okay, cool. So it's just basically a terminology for a steps of a process, right? This cycle continues indefinitely until the shell process is terminated. Your shell should follow the same cycle. Display the prompt, right? We have a prompt. Then wait for the line of input. Print this if for any command the user enters like the previous stages and return to step 1. For example, if the user types hello, your shell should print this and then display the prompt again. Okay. The tester will execute your program like this. It will then send a series of commands to your shell. After each command, the tester will then verify that your shell prints the message, displays a new prompt before the tester sends the next command. The exact number of commands and names will be random. The loop should run indefinitely. The tester should terminate your program when the test is complete. Okay, so we just run indefinitely and terminate. We don't terminate on input, we just do it indefinitely. Okay. 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 So what we do is, can we set up a function called like, which just, no, we don't, I guess we need a function. I guess we can just wrap it in the main loop. But our main, so we need a, do we want to abstract out this into a separate function and then run a loop over that function? So if we have int shell, or int, we'll say int, we'll keep it, we'll say int REPL, right? Taking in int argc and char star argv array, right? We're going to take our input here and put it into this function here. I guess we need to have REPL come above main, right? Main, oh, yeah, maybe, so main just runs. We call for, right, and then we're gonna just do call to REPL. Well, this takes in inputs, right? So we have to input our counter. Right? And that'll just run and do that over and over and over again. So if we try this, non-void function returns if it does not return a value. Okay, so that's right. So this needs to return a value. I guess we'll just return 0 here for right now. And then line 31. So expected expression int argc. Expected expression for both of these inputs. Expected expression. Oh, it's taking in an integer count. Oh, yeah, maybe we weren't supposed to do it like this. Because you don't, you need to feed an integer here, right? Expression. And an array here. So let's back it up. So definitely not like that. So this just sets our outputs to empty. So I guess we just loop here. right? We loop here. Right? We loop here. And then at the end of this, we would need to set argc and argv to null. We say argc equals to 0, and then we clear char. Do we say that argv would we have to clear out the memory? Okay, let's see here. Okay, maybe not. Maybe it just overrides each time automatically. I think I'm overthinking a lot of stuff here. Okay, so it does override it automatically. Okay, so it's a lot more simple than I'm making it out to be. Okay, so that's where we're at so far here. I guess what you could do if you wanted to is you could just turn this to a while one. Right, okay. So let's do it. My stomach's growling. Oh. Okay. Moving on. Hey, moving up. Let me know if you guys are completing this alongside me here. Welcome in, everybody. Appreciate you joining me. And if you're new here, subscribe and chat with me. Thanks for being here and hanging out. We're trying to get better at C programming by building our own shell in C and challenging ourselves here. Okay. In this stage, you'll implement the exit bulletin. In this stage, you'll implement the exit bulletin. The exit bulletin terminates the shell. Oh, sorry, built-in, not bulletin. Whatever. In this stage, you'll implement the exit built-in. The exit built-in. The exit built-in terminates the shell. Built-in commands are handled directly by the shell without starting a new process. The exit built-in terminates the shell. Built-in commands are handled directly by the shell without starting a new process. When your shell receives the exit command, it should terminate immediately. The tester will test our program like this, and then we'll send an invalid command to your shell followed by the exit command. The tester will verify that your shell terminates after receiving the exit command. Okay. So we need to determine if the command is the exit command. Right? So we have here, which prints the value. So I guess can we? No, we don't want to do that exactly. We want to make sure it's in there. We need to make sure that that string is in that is equal to that. So we have to check it like character by character. Hmm. Hey Spider, how's it going? Thanks for coming in. So we need to understand how to. Okay, we can do stir compare. So let's do. Um, so right, let's go to our functions here. Let's look at stir comp. Right? So this is a built-in function which compares two strings lexicographically. It takes the strings array of characters arguments, compares these two strings, and then returns some value as a result. Okay, so let's go ahead and let's use our new knowledge of macros as well from our reading last night. If you guys didn't catch that reading of C Programming a Modern Approach last night, make sure you guys go look at that. We read all about macros, finished chapter 14. So let's define um, the exit command to be a char star um, a char star how did my brain, I can feel it just, I can feel the thinking going on. This is where the learning happens. So when you feel that stress, that strain, like, oh, that makes you want to give up, that's what you got to push through. Because that's how you know that you're learning. Okay, so let's go to chapter 14 notes from our reading. I want to look up the macros that we learned for. I thought we could use like a string and a macro somehow. So this defines, this makes an ID. No. My stomach's growling. That replaces all of the values, or concatenates the two. Can I define a macro? Let me see here. Um, define macro of a string. Oh, so it'll just replace them before running. It doesn't actually like look for them. So it's not really like something that we. Yeah, so this is pre-processing, so maybe it doesn't really apply here because we're not substituting this in, we're looking live for input. So maybe not. So we could define a variable. So we just need to make sure and just do stir comp with, okay. So let's do this. Command buffer new line, right? This replaces it. And then moves on. So what we're gonna do is we're gonna say stir compare, right? Command buffer, and we're gonna do quote exit. Because this is a char star. So can we put in a string there? And so the stir compare will return okay, let me just do this, I guess. Char star exit is equal to second string so bad here. So char star exit. Just say exit is equal to quote exit. Okay. We stir compare exit here. Right. So if they're the same, it'll return 0. So if returns 0 since they're identical, so 0 or like 1 is true. Or positive if 1 is greater, or negative if 1 is less. So we want to say if not stir. So I will say if stir compare exit equals to 0. Right, what we're going to do is we're going to return 0 here. Or I guess we could just break. I guess we could just go here and say printf and say like right, something like that. So let's try this. Nice! Yes! String compare. Good call, Mike. Um, okay, cool. I think that's good. So let's go ahead and run our code crafter submit. No! Reform! Oh, it didn't like our output. Okay, screw you. Come on, I'm trying to have fun here. Let me have some fun. Can a boy have fun? Can a boy have fun? Come on. Alright, cool. We're doing good. See, I'm trying my best to not like look at the hints right away. I'm trying to think it through. We got through that one. We recognized stir compare there. Um, right? So feels good. Okay. So maybe I could define, right, a exit macro to be quote exit, right? So let me look. I'll look this up. I'll say, is this macro valid for a string? Yes, this is a valid macro. Okay, perfect. So then if we go here and just put in our macro, we're good to go. So we'll make a thing here. We'll say check for exit command. Nadim says, do you have a idea about AI research? Why I also see big research stuff coming out of big labs, big universities. Do you think someone can work as independent researcher? Crazy question. I'm not saying like it's a bad question, but it's like a very, very broad, abstract question that doesn't have any real application to me, honestly. So I'm sorry, dude. You I kind of maybe you should do some background research on who I am before asking that kind of question. Not that kind of guy. Okay, cool. Nice. I think we're good here. So the Echo built-in. All right. Echo built-in. We're building a show. We're building a show. Okay. The Echo built-in prints its arguments to the standard out with spaces between them and a new line at the end. Example usage. Echo prints arguments to the standard out with spaces between them, a new line at the end. Echo hello world repeats hello world. So basically just echoes whatever we say. Test. The tester will execute your program like this. It will then send a series of echo commands to your shell. That makes sense. This is also a good opportunity to learn like what a shell does. Like these commands, you see them all the time, and it's kind of unless you sit down and really like learn them one by one, it's kind of it can be easy to just to like forget about them. Okay. Most languages standard output functions like console.log, print, println, automatically add a new line, which is what you want here. Okay. So let's write a macro, right, which is going to be echo. Got a hair. Hair in my mouth. Okay. So then what we're going to do is I'm going to write a function. I think I'm going to try int check int check command, right, given a char star okay. And what this function is going to do is we're going to match case. We're going to match. Is it match? I think it's match, right? I think it's match case, right? Switch. Match is Python. So we're going to switch on the input so we're going to switch on C. We're going to have a case of exit macro. We're going to return 0 or break. Case of echo. Do we call a function here? Do we call a function here? Echo. We're going to echo the command. Oh. Maybe I'm going to hold off on this for right now. Okay. If stir compare command at buffer and exit equals to 0, we break. Right? If stir compare command buffer so this is the full command, so we would need to identify I want to see this one. Stern compare. Okay, that's right. So in stern compare, you would give input and echo with a space, and you have to match all 5. Wait, what does that third argument in stern compare mean again? Compares the first n characters. So you have to compare up to some number of characters. So if you only want to compare the first 3 characters, in this case we're comparing the first 5 characters. Ah, yeah, that would be perfect. So we're going to do stern compare for command buffer, and given our, but our thing is our echo statement has a space like that. So command buffer given our echo macro with five here. Now we say that's equal to 0 because we want to make sure that does compare perfectly. And now we handle the echo. So we could oh, this is just a list of all the arguments. List of characters. Which all of our arguments? Which arguments? So to extract out the arguments, I guess we just print or we just read until we have white space, right? So we know that we're on index 0 is the E. So we're now on index 5 to read from. So we would just do put S. This reads until, so we would want to do put S, F put S. Want to read command buffer index of 5 size of command buffer less than, we know that we have chars in there, characters, so less than size of int times 5. Sorry. Size of char times 5. We read from the onto the standard out. And then we would continue. And then we would guess printf a new line character. Let's try it. Okay. too many arguments to function call. Expected 2 has 3. Okay, let me look up. Okay, so maybe we just print f. Let's just print f and insert the command buffer index of 5. Let's try that. Well, that's going to print a single character. We want to put s for printf. Until it encounters a null character is encountered. Oh, okay, so let's just do put s then. I thought it was until a space was encountered, but no. Oh, sorry, not there. Okay, let's try that. Okay, right, so this is a pointer. Oh no, this is a character, so we need the address of that character. Start. Yo, no! Command not found. Shoot. I guess we continue here. Yes! Yes! Woo! Nice. All right. Sweet. Let's go. Okay. All right, that was good. I'm doing good. Hmm. So what they do is they do if stir compare input echo. So they compare echo, right? And then they take input and then add 5 characters to it. We just go to command buffer and out of 5. And they're using the input. Where did they get this input? I'm not sure why they changed input from the command from previously, but that seems kind of, I know, weird, but let's see if we got it. Yes! Woo! Let's go. All right. Feels good. Okay, let's mark this as complete. Leave a like on the stream if you're enjoying so far, you guys. It's a fun one so far. Okay. The type built in. Here we go. Type. I ain't got no type. Ah. C programming is the only thing that I like. All right. Here we go. The type built in. The type built in is used to determine how a command would be interpreted if it were used. It checks whether a command is a built-in, an executable file, or unrecognized. For example, type echo, echo is a shell built-in. Type exit, exit is a shell built-in. Type invalid command not found. For this stage, you'll have two cases. For built-in commands like echo, exit, and type, print command is a shell built-in. For unrecognized commands that you don't have any match built-in, print command not found. We'll handle executable files later. Okay. The tester will only check for built-in commands and unrecognized commands in this stage. Type itself is a built-in command, so type should print. Type is a shell built-in. Okay. Cool. The shell course was free only for May, but many people tried it this month. They extended it for June too. I'm starting it now too. Yeah, seems like it's getting some popularity here. So I'm gonna download this VOD um, to my computer. I'm gonna chop it up and re-upload it. I forgot to start the recording, so I might start the recording now just to have in case I have a backup for at least up to this point. So I just started it. Okay. Okay, so let's do the type built-in now. So we need to do a type built-in, which just determines whether the type is one of our defines. Okay. So how would we do this? Let's think. So obviously we need to do stir compare for type, right? And if it is, we would need to take the input that they gave and okay, got you. So this would be type. We'll say if, right, we're going to compare two strings, stern compare, right? We're doing stern compare this time to compare a specific n number of characters given the command buffer and our new macro for hashtag define type equals to quote type space. I'm not sure if this is the best way to be doing these using macros for these, but I'm just trying something because we learned about macros yesterday in our reading of C Programming, A Modern Approach, Chapter 14. So if you guys haven't checked out that reading live stream, go check it out. I'm also going to chop up the recording and upload the condensed version to the channel, just like I have for all the other chapters so far. So we have command buffer given our type, and we're going to read 5 characters of this, and we're going to check to make sure that this is equal to one another. Okay, so this is our type. Let me also go up here really quickly and add in, this is our echo, and then this is for our exit. So if this is true, we know our command buffer is, so it's actually a lot easier than I think. So it's actually just going to be printf to printf to we would say, what is the thing? It's like, so we would put in this is a shell built in, right? And then I guess we'd get a new line here. And then what we would do is we would insert into here command buffer index of 5 forward to read forward on. And we would have to insert the address of this. No, this is just expecting a string to be inserted directly. So I don't think this is expecting a pointer. So let's try it here. Okay, so it is trying to directly insert a single character into there. So I guess we could say put s. Right? We'll insert basically what we have here. We'll take this. And then we'll say and then we can just get rid of this, do a space here is a built-in, and then we don't need this. Now I'm not sure if I'm, oh, whoops. Oh. Shoot. You guys are probably like, Mike, semicolon! There's a semicolon! So put s does, so put s automatically adds a new line character. Really? Put s puts a new line character? A new line character. Okay. Interesting. Okay, that's right. So if that's the case, we don't want to do that. We guess we just say we just print f, insert a string, right? And we would do, and we would do command buffer value of 5, but we're going to do the address. Because is %s expecting a physical string or a pointer to a string? Let's try it out. Type echo. Echo is a shell built in. Okay, cool. And so then we just need to continue off of this. And then that should pass. Echo type. Oh, sorry. Type, type is a shell built-in. Yes. No! Dang it! Invalid orange command is a shell built-in. Oh. What? How did that pass? Hold on. Invalid type invalid orange. Invalid orange is a shell built-in. What? Type defined as type equals space or type space. If stern comp for the command buffer and type are equal to one another for the first 5 characters. Oh. Oh, I see. I see. We're not checking to make sure that it is one of these valid types, right? Hmm. Okay, so what we'll do is we'll just do this. We'll do a switch statement. Right? And for the case switch on right? So we obviously we could have like we need some sort of like data structure to house our current commands. Right. Well, I'm gonna try to go for one of the. Oh, really? Um. So if it's type, we need to check that it was either echo, type, or exit, right? Type exit. I guess you'd have to stir compare every single one of these, but that seems like really annoying because you're already stir comparing. Yeah, you have to do that. So if stir compare command buffer index of 5 if the address of command buffer index of 5 can be compared to exit, if this, or I guess all of these again, like we're comparing these strings over and over and over again, which seems so silly, but I'm kind of blanking on a way to do it. Exit type echo if any of this or this or this or this equals to 0, then you would do this. Else you would printf and insert %s, right? %s um, not found, and we would insert into here the address, the command buffer key of 5. Continue. Okay, let's try this. So let's do, that's command not found. Okay. Echo help, or whatever. We would do type hello, hello not found. Okay, I need a \n there. Type echo, echo not found. Type echo, echo not found. So if any of this or this or this is a shell built in, if stir compare equals to exit, or type, or echo equals to 0, printf. I started to learn Golang, and I think I'll try to build it after also completing HTTP client. Nice, dude. Hey, Turok, can you share the docs? What docs? These ones? It's just codecrafters.com. Or codecrafters.io, sorry. Okay, so I'm gonna get a little bit of help with this one. So let's get a little help with this one. No code. Don't show me code. I am trying to implement a type function, type command for a shell. Return 0 when strings are equal, not non-zero when they are different. Oh, okay, that's right. Type exit what exactly is stored in the substring you're comparing. Okay, so let's back up here. It's not exit, it's -1. I guess let's just back up real quick to just one circumstance. Maybe just this one instance here. So if stir comp for the string at command buffer index of 5, so echo 0 print. So we wanted to need to get the input. So do we need to do, because this one's tough. Oh, these docs? Yeah, they're on my GitHub. C Programming a Modern Approach. All of these notes are on my GitHub. Got exercises, programming projects, a lot of good stuff in here. Over the course of the year, we've been reading this book. It's a long book. Okay, so I'm a little stuck here. Did it give me an option for a hint? Didn't give me a hint. I want to see it yet, no. Ah. Okay, so what did it suggest here? It said identifies type as the command, uses the next token to exit as an argument. If for input type exit, what exactly is stored in the substring you're comparing? Hmm. Okay, so the prob we have a so for problem we have stir compare buffer type. Okay. We are trying to then identify. Okay, so we need to, I guess, do like this. Maybe like we have char input. I don't know. I'm kind of stuck here. It doesn't give me any hints on this one. Those hints were helpful. Building type. Hmm. Okay, let's see. Um, let's get some help here. Having trouble. Suppose the user enters type exit. I evaluate the comparison. Okay, so 0. Okay. Hmm. So then how do you logically compare or bring them all together in like it can't be an expression. Can you do like can you switch at the command buffer index of 5? That's an address, no. So if stern comp command buffer type 5, so this is saying that we're in the type command is identified. We need to, so if it's one of those zero. So then how do you propagate the true statement forward. So if we were to say, like, stir comparison command buffer index of 5 with echo, that's equal to 0. Or this again, but equal to type, or exit equal to 0. So if this, right, echo, type, exit, for all three of them equaling to 0, if either or of them equals to 0, not comparing all of them to one singular instance of equaling to 0, but all of them individually in their own instance equaling to 0, or in any case, for these three cases, we would do the printf for quote %s and say is a shell built-in \n and insert in command buffer index of 5 the address of that point for the pointer to this string, right? Else we would just printf that invalid command not found. So it would be a similar instance to this, but it'd be here not found. Continue. Okay, so let's try this. So we need to compare, the address. It's taking a pointer of these values. Rather than a single character. Command buffer is a pointer in itself, right? Stir comp echo and 1 generate expected expression. That seals there. That's there. Okay, so we need to wrap it in one more set of parentheses.
Hey.
Hey, I'm on stream. What's up?
Love you. Don't touch me.
Are you sweating? Are you showering and stuff? What are you doing? How long are you gonna be here?
No, because we're gonna go swimming, so I'm just gonna dry off. And I'm here for like 5 minutes, 10 minutes. I'm gonna eat lunch, have some eggs, and then I'm gonna head back over and maybe swim or.
Okay, I'm almost done. So just give me like 2 minutes. I'll come down and say hi.
Yeah, no worries. Take your time. I'll be here like 15.
Okay. Um, what sort of cool stuff are you gonna put in your shell? We'll find out. Maybe I can really expand it out. Who knows, Jimmy? What happens if the input is more than that? Well, for right now, we'll deal with that when we get to it. We'll deal with that when we get to it. That was a suggested one. Input side. Okay, so we have we need to wrap our if statement in just a larger set of parentheses here. Right, so this corresponds to this. Good. And then we need a parenthesis. Oh, that good there. That corresponds to that good. Nice. So now I think that this should work. Famous last words. Echo, type. Okay, that works. Type, type. Type not found. Shoot. So if stir comp let me see here. I think we're close, but I'm just getting a little bit. Been going for a while here, so I'm getting a little fuzzy. Hmm. Okay. I think I'm gonna take a break here, you guys. Grab some lunch. I'm really hungry. My brain is getting fuzzy. But so I'll be back later. I guess this was episode one of implementing and writing my own shell in C. If you guys want to see more episodes of this, want me to continue on with the series, let me know. I'm having a lot of fun doing this and building it. We got stuck on the type implementation here. We need to figure out. We have a couple of issues. I think using the buffer index 5 as our comparison is pretty fragile. So we might want to see about tokenizing out the inputs somehow. But yeah, anyways, thank you guys so much for being here, and I appreciate you guys. Make sure you guys like and subscribe. I'll see you guys next time where we'll continue on in episode 2, finish up this type built in, and I think we have 2 more things for this first section here. So we made some really good progress on it, but it's a pretty big project. So thanks so much for being here and hanging out with me. This is a lot of fun. I'll see you guys in the next one. I'll upload this back to the channel, so it should be a cool little series. Peace out, guys. Have a good one.